Hello, I hope that you're doing alright. My name is David Ramos and I'll be the person explaining this series of videos on calculus and its applications in biomedical engineering. So the topic that we're going to be talking about today is diffusion, and the case is diffusion of topical glaucoma in the cornea. So there is a treatment to decrease intraocular pressure, so this is the pressure inside the eyes, of people that suffer of glaucoma. So glaucoma is a condition where the optic nerve which connects the brain to the eye becomes damaged. And this treatment involves applying the drug brimonidine. The usual treatment is to administer eye drops containing this drug, but there are limitations such as the difficulty of the adherence from the patient's part to the regime of applying 3 drops per day, and the other limitation would be that part of the drug does not stay within the eye. So an alternative method is to deliver the drug through a contact lens where the drug will diffuse into the eye. In this study, the researchers ended up getting a graph looking like this, where we have the concentration of the drug against time. This represents well how diffusion takes place throughout time in the treatment. As we know, the greater the difference in concentrations on both sides, the greater the rate of diffusion. That is why at the beginning, the exchange of the drug concentration increases as the contact lens is settling in, to then decrease as more of this drug is on the side where the eye is, to finally reach this sort of plateau. To simplify things so that we can teach basic differentiation, we simplified the graph that I showed previously to this sort of parabola, which is represented by the equation that you can see on the screen. If we want to calculate the rate of change of the equation shown previously, then we want to use differentiation. Anytime that we get asked to find the rate of change, then that's when we want to use this field created by Mr. Newton. So what we do is that we take this equation and we separate the numbers from the x's so that we can now know what we want to differentiate, which in this case is the x's. So then what's going to happen is that if we look at the x to the power 2, then we have to differentiate it thinking that the exponent 2 is going to be subtracted by 1. So that's why we just end up getting x at the end. And then the original exponent 2, it's going to go to the other side, and it's going to be multiplied by 1x in this case. So then that's why these 2, we then multiply by the minus 1 over 2. So we end up getting minus 2 over 2x, which is just minus x. And now if we're talking about 4x, so the exponent of x would be 1. So 1 minus 1 is just 0. That's why it ends up disappearing. And that's why we only have the plus 4. So the final differentiated result is minus x plus 4.